All right, the cross slide from problem set 5. This is the first time we're seeing a key seat. A key seat locks a cylindrical shaft to a cylindrical hole. This one and the column bracket, the next one, will have the same feature. It's actually very easy to create. We have a rib. We have ribs on both sides. It is tangent to this cylinder, so tangent line construction. By adding a midplane, we can create a tangent sketch and extrude in both directions equally. I would not use the rib tool here. Your rib only goes in one direction, so if I sketch both ribs, one wants to go to the outside and one wants to go to the inside, or vice versa, I would do this with a sketch and an extrusion, not using the rib tool. By adding a midplane, I can also sketch the cylinder and this rib underneath. Take note, the overall width is 70. The length of this cylinder is 50. So 70 minus 50 is a difference of 20. And to center it from this machine surface to this side, this front side of this part, would be a distance of 10. This rib underneath is 12 millimeters away. My suggestion is to come back and cut this. Cut into on both sides. Since I have the plane, I could mirror, and that is actually what I'm suggesting. So, we do have machine surfaces. We have symbols for machine surface. No hatch pattern, and then we have some casting fillets of 2. Right. Being that this part is in millimeters, I would start with the base material first. I am in millimeters. I'm going to start with the base material. There is this angle groove that goes through the bottom. And we'll just add some dimensions here. I have an overall width of 70. The overall height of this base material is 25. That dovetail groove is 12 millimeters from the base. And this takes place 18 millimeters in. Same on the other side, or I can measure the 34 in between. At that edge. From here to here is another 18. That sets this distance in between at 34. Angles. You have two 60-degree angles. And this side is 60 as well. My overall length on the base is 100 millimeters. All right. Adding a midplane. By adding the midplane, when I create that cylinder and the ribs with tangent line construction, I can extend in both directions equally. By having that midplane, we can reference it if we want to mirror, or come back and reference it for another sketch. I'm going to select both opposing surfaces to get a plane that runs down the middle. I am now going to sketch on this plane. I would start with a line to ensure that that cylinder is centered. I have an origin. I'm going to come up and I'm going to set this outside diameter. I'm going to cut the hole in the key seat at the same time later on. So points of tangency. I am not on plane. Oops, that was a circle, not a line. I'm not getting a snap point to this edge because it's not on plane. I am going to create the tangent constraint here. Well, now I need to add a constraint that this edge and this line are coincident. So this is tangent. We can add tangency. Oops. By adding the constraint independently, but I still need a constraint that these are coincident. All right, to my dimensions. The distance to the center of the circle from this bottom edge is a distance of 68. Extend that back out. Okay, still tangent. The diameter of the outside cylinder is 23, and we have two 75-degree angles. Sorry, 60-degree angles. Again, I'm going to bore this out with my key seat at the same time, but being that I'm creating the rib, I cannot extrude in the same direction with two different dimensions. I'm just going to extrude the rib at 10 millimeters wide. So instead of extruding in one direction, I'm going to extrude in two, symmetrically. I could do half length, 5 and 5. I'm going to do the whole length at 10 millimeters, 5 to each side of the plane. From here, I'm going to add the cylinder and the rib. I have this plane already. I am now just going to create a new sketch on it. I already have my circle that I can now make concentric. This and this are concentric, and this diameter again is 23. By using this center point, I can generate the rib. I can come up into this circle, but I need to set a width of 10. I am only looking for this upper section, so I need some sort of parting line to constrain that. I want to make this line and this line collinear. That really limits that I am going to extrude this and this cylinder at the top. I want to go in both directions, and I'm going to do the overall 50 and then cut that rib back. Not cut. I want to extrude that one. Not that face. No, I can't get in there. I don't want to cut it. I want to join it. Okay. Now I'm going to cut this back 2 millimeters on both sides. So I have a surface that I can sketch on, a combination of a rectangle and a circle. I just want to cut this bottom section. I'm going to cut 2 millimeters in. Since I have this plane, I can reference it again. I am going to mirror this feature, which was this cut. Just the cut. I want to mirror this. My mirror plane. Okay. So now I created that on the other side. To the key seat. drilled hole with the broach key seat, center rectangle, and a circle. Reference the center. The bore diameter is 15, and I want to create a key seat. Center rectangle. If I hover over this center and project straight up, I'm getting a guideline. This is the overall dimension. So your key seat is listed as 3 by 5. So 3 by 5. It is now not centered. There we go. The key itself is what is being measured. This is going to get cut all the way through. I'm just going to do them both at the same time. Casting fillets. You have casting fillets that are a radius of 2. All my casting fillets are on. Material is malleable iron. And you have machined surfaces. The key seat is cut, is a machined feature. And you have machined surface symbols for the bottom and the dovetail cut.